In 2016, deep inside Monterey Canyon, a research sub switched off its lights, and the darkness answered back. Not with silence, not with emptiness. Something moved where nothing was supposed to exist. The sub was already 2,500 meters below the surface. Pressure exceeded 800 atmospheres. Water temperature hovered just above freezing. Sunlight cannot reach this depth at all. In this part of the ocean, vision should be meaningless, and light should be impossible. When the lights went out, everything disappeared. Then a faint blue-green glow appeared in the darkness. It didn't drift aimlessly. It curved, pulsed, vanished, and reappeared somewhere else, as if reacting to something unseen. At first, the explanation seemed obvious. Equipment interference, reflections off particles, maybe plankton reacting to motion, something commonly seen in shallow water, so the sub stopped completely. No movement, no disturbance. The glow returned anyway. This time, it came back in patterns. Controlled, repeated, intentional. That ruled out debris, reflections, and technical error. Something alive was producing light on purpose at a depth where light should not exist at all. At 2,500 meters, the pressure is comparable to stacking dozens of jumbo jets on a human chest. Survival for us would be instant death. For these organisms, it is a normal environment, one they have adapted to completely. Imagine total darkness in every direction. No horizon, no surface, no reference point. Only cold water and slow-falling particles drifting like ash. Then one glow appears, then another, then several more. This wasn't a single animal. It was many, using light to signal, to hunt, and to avoid becoming prey. That leads to an uncomfortable question. Producing light requires energy, and energy is the rarest resource in the deep sea. Food can take weeks or months to find. So why evolve something so costly in a place where survival is already this difficult? Forget the idea that this glow exists for beauty. That explanation doesn't survive reality. Down here, light is control. It is camouflage, deception, and weaponry combined. The ability to choose when you are visible and when you disappear decides who survives. And if light means life in total darkness, then the real mystery isn't how deep-sea creatures glow. The real mystery is why the darkness left them no other choice. To understand why light matters down here, you first have to understand how deep really is. At around 200 meters below the surface, the ocean changes character. Sunlight weakens, colors begin to vanish. Reds disappear first, then yellows. What's left is a dim blue haze like permanent underwater dusk. Go deeper. By the time you reach 1,000 meters, you enter what scientists call the midnight zone. This is the point where sunlight doesn't fade. It ends. Photons physically cannot travel any farther. No sunrise, no shadows, no natural light of any kind, ever. And yet, life doesn't stop. Below that, the ocean keeps descending. 3 kilometers, 4. In some trenches, nearly 11. At 4,000 meters, the pressure is extreme enough force to crush steel if it isn't specially reinforced. For comparison, that's like placing dozens of fully loaded jumbo jets on a single human body. Nothing biological should function here, and yet it does. So how do we know all of this? We don't guess. We measure. Instruments called CTD sensors track conductivity, temperature, and depth. Light attenuation models calculate exactly how far different wavelengths can travel. Submersible photometers confirm what theory predicts. Below the midnight zone, solar light is zero. Not low, not faint, zero. This is important for one reason. In a place with no natural light source at all, any light you see was made by something alive. And here's where things get strange. Surveys show that more than 75% of animals living below 1,000 meters can either produce light, sense it with extreme sensitivity, or both. That's not a coincidence. That's a rule of survival. When darkness is absolute, light becomes information. Down here, a single flash can mean food, or danger, or mating, or deception. A pulse lasting less than a second can decide whether an animal eats or becomes a meal. So this isn't about glow-in-the-dark creatures being rare oddities. It's the opposite. In the deepest parts of the ocean, glowing is normal. Not glowing is the exception. And that raises a deeper question. What kind of world forces life to invent its own light just to survive? To answer that, you have to understand the environment that demanded it. To understand bioluminescence, You have to understand the world that demanded it. This part of the ocean is cold almost all the time. Temperatures stay between -1 and 4 degrees Celsius. Not occasionally, constantly. Cold enough to slow chemical reactions. Cold enough to make movement expensive. Cold enough that nothing happens quickly unless it absolutely has to. The pressure here is crushing. Anywhere from 100 to over 1,100 atmospheres, depending on depth. Every square inch of a body is being squeezed non-stop. Soft tissues compress. Gas-filled spaces are impossible. Every organism here is built to exist under force that would destroy most life instantly. Oxygen is low but stable. There are no storms to stir things up. No waves. No seasons. The water barely moves. Food doesn't arrive in meals, it arrives in fragments. Tiny particles drifting down from the surface. Dead plankton. Fecal pellets. The occasional carcass that feeds an entire community for months. This is what scientists call marine snow. It looks gentle. It isn't. It's unpredictable. It's slow. And for many animals, it's the only reason they're still alive. And yet, this place isn't empty. Anglerfish drift here, conserving energy, mouths larger than their bodies. Lanternfish move in loose migrations, carrying light with them like a living signal. Vampire squid hover almost motionless, using flashes not to attack, but to avoid being noticed at all. Nothing here wastes energy. Every movement has a cost. Every decision matters. That's why bioluminescence isn't an accident or a novelty. It's the logical result of this environment. When food is rare, speed is dangerous. When darkness is total, sight becomes power. In a world like this, being invisible all the time is a disadvantage. Being visible all the time is a death sentence. Survival depends on control, on choosing the exact moment to be seen. That's why glow solves a problem nothing else can. And once light exists in this world, it stops being a curiosity. It becomes a tool, a language, a weapon, which leads to the most unsettling part of the story. Because once light can be controlled, it can be used to kill. So how did light become one of the deadliest tools in the ocean? Most people imagine bioluminescence as something passive, soft glowing bodies drifting harmlessly through the dark. Forget that. In the deep sea, light is rarely neutral. It is used with intention. Take the anglerfish. It doesn't chase prey. Chasing wastes energy. Instead, it waits, motionless. Its glowing lure hangs just in front of its mouth, pulsing faintly. Small animals mistake it for food. They move closer. Distance disappears. The strike is instant. No warning, no escape. Other species use light in the opposite way. Hatchetfish glow on their undersides, not to be seen, but to erase themselves. Predators looking up from below expect to see a silhouette against faint surface light. The glow cancels that outline. From underneath, the fish vanishes. From above, it's already gone. Then there are squid. When threatened, some species release clouds of bioluminescent fluid instead of ink. The flash overwhelms a predator's vision, buying seconds. In the deep sea, seconds are enough. Confusion means survival. But the most unsettling strategy belongs to dragonfish. Some dragonfish produce red bioluminescence. Red light shouldn't work here. Almost no deep-sea animals can see it, but dragonfish can. That gives them a private hunting channel. They illuminate prey without being detected, like shining a flashlight no one else can see. The advantage is absolute. This creates a strange contradiction. Despite living in darkness, many deep-sea animals have eyes far larger, relative to body size, than surface species. Vision didn't disappear down here. It intensified, because when light appears even briefly, it carries information worth everything. And that brings us to diet. Copepods are common, drifting everywhere. Lanternfish are energy-rich, worth the effort when encountered. Krill form predictable swarms. Jellyfish are low resistance, easy calories. Every glow, every flash, every pulse is calibrated to secure one of these meals, or to avoid becoming one. Nothing here glows by accident. Light is not beauty. Light is strategy. And once you realize that, a final question becomes impossible to ignore. If bioluminescence works this well, what don't we know about it yet? The deeper question is this: if bioluminescence works so well, what don't we understand about it yet? The simplest answer is uncomfortable. We've barely been there. Less than 5% of the deep ocean has been explored directly. Most deep-sea species have been seen once, sometimes only on camera, sometimes already dead. Many never survive the journey to the surface. Pressure changes rupture tissues, light organs collapse, behaviors vanish the moment conditions change. Some species only glow under threat, others only during feeding. Some may glow in ways our instruments don't register at all. Human eyes are tuned to a narrow slice of the light spectrum. It's entirely possible that signals are happening down there that we simply cannot see. There's also the problem of time. Deep-sea animals move slowly, they react slowly. They can wait minutes, even hours, before responding. A brief expedition misses most of that story. We arrive, observe for a moment, and leave. Whatever didn't happen in that window remains invisible to us. And yet what we have learned is already changing how we see the world. The same chemical reactions that power deep-sea glow are now used in medical imaging. They help doctors track cancer cells. They reveal infections. They light up processes inside the human body that were once completely hidden. A survival trick invented in total darkness is now saving lives at the surface. That connection matters because the deep sea isn't separate from us. It regulates climate. It stores carbon. It absorbs heat. What happens down there shapes the planet we live on, even if we never see it directly. And the more we alter the ocean above, the more pressure we place on the world below. There's something humbling about that. In the darkest place on Earth, where life should have failed, it adapted instead, not by becoming stronger, not by becoming faster, but by learning when to shine and when to disappear. And that leaves us with one final thought. In a world without light, life didn't give up. It learned how to create its own.